Hello everyone, welcome to today's video. Today we are breaking down a fundamental concept in operating system, user mode versus kernel mode. Have you ever wondered how your computer prevents apps from crashing the entire system? Or why some programs can access hardware directly while others can't? Well, it all comes down to these two models. Let's start with user mode. When you open a browser, play a game, or write a code in an editor, your program is running in user mode. This means it has limited access to the system's resources. It can directly interact with hardware or memory. Instead, it must request. It can't directly interact with hardware or memory. Instead, it must request access through something called system call. The operating system acts as a middleman, ensuring that apps don't interfere with sensitive system processes. User mode is where applications like Chrome, games, and text editors run, providing a safe environment with restricted privileges to prevent system-wide issues. No direct access. In user mode, applications do not have direct access to system resources. Instead, they must have request permission from kernel via system calls to perform privileged operations. Now let's see what kernel mode is. This is where the operating system itself runs and managing hardware, memory, and processors. Kernel mode has full access to the system, which makes it powerful but also risky. If a program in kernel mode crashes or has a bug, it can take down the entire system. That's why only trusted code like device drivers and core OS function runs in kernel mode. Kernel mode is where the OS core functions such as memory management, device drivers, and process control operate, providing direct control over the system resources. Due to its high level of control, bugs in kernel mode can crash the entire system, emphasizing the need for careful and robust coding practices in kernel development. Let's compare user mode and kernel mode side by side. Coming to the access level, user mode has a limited access to the system resources, while the kernel mode has unrestricted access to the system resources. Coming to operation perform, user mode where the user can only perform the user operations. In the kernel mode, the user can also perform the system operations too. Impact of bugs. In the user mode, the impact of bugs is restricted to the application only, while in the kernel mode, it can affect the entire system. Coming to the security. In user mode, it relies on the OS for security measures. In the kernel mode, the security is responsible for the system-wide security policies. Coming to the memory management in user mode. Virtual in user mode, it has a virtual memory and managed by the kernel. And while in the kernel mode, direct access to the physical memory is given. At last, we'll also see a real-world example showing about the system calls. Hello everyone. Let's see a practical example of user mode and kernel mode with the help of a system call. Let's say we open a command prompt and type ls command. It lists all the present working directories and files in the specified path. To trace the system call, we need to type the command strace in the command we want to trace. Yes. Here we'll get a bunch of system calls which is currently running a computer. Here we'll see a command Write command. It's a file handler command. Is also a write command. These all are system calls which is running in a Postman application in our computer. This is a practical demo of system calls which helps us understand user mode in Kernel Mode. Thank you.